Hi everybody, my name is Joey and I'm the Perfect Score Tutor. I've gotten perfect scores on both the SAT and ACT, but today I'm here to help those of you who are prepping for this upcoming AP Precalculus exam. I've gotten my hands on this AP Precalc sample test and I wanted to work through some of the questions for you. So we have FRQ number 1 in front of us. This is a calculator active question. They give us a table representing f. They give us the function g, and part A is asking about this function h, which is defined as g of f of x. So they say find the value of h of 4. So here's how I do that. I write h of 4 is equal to g of f of 4. And then the way we read this table is if we want f of 4 would equal 3. So then my next step would be write g is equal, we want g of 3. And then we can plug that into our equation, right? G of 3 would be 2 times ln of 3. Now I go ahead and plug that into my calculator and I get the number 2.197. And remember that you want to round to 3 decimal places. Part 2, it says find all values of x for which f of x is equal to 3 or indicate that there are no such values. So now we're looking for an input that yields an output of 3. So these are my outputs. So then we have these inputs that would give me 3. So then we could say something like f of 2 is equal to 3 and f of 4 is equal to 3. So then you could say something like f of x is equal to 3 when x is equal to 2 and x is equal to 4. Part B says find all values of x as decimal approximations for which g of x is equal to 3 or indicate there are no such values. So the question gives us that g of x is equal to 2 ln x, so I'm just going to substitute that expression into there. So I get 2 ln of x is equal to 3. Next step is to divide both sides by 2, so I get ln of x is equal to 3 over 2. Now, to invert or cancel out this natural log, we're going to raise both sides to the base of e. Remember that e is the inverse function from log. And so then we get x is equal to e to the 3/2 power. Now, we go to our calculator, and we're going to plug in e to the 3/2 power. And then we get 4.482. Remember, on the pre-calc test, they want 3 decimal places. Now, let's say for whatever reason you're freaking out and can't remember how to actually solve an ln equation and get a decimal and don't remember that it's e to the 3/2 power. Another thing that you can do is you can just graph the function, so 2 ln x, and then we're going to graph y2 is equal to 3. Then we're going to hit graph. So this is our ln function right here. That's y equals 3. Then we're going to go second calc, and then we're going to find the intersection. So if you're using a TI-84, all you need to do is hover close to the intersection and hit the enter 3 times. I'm using a slightly different calculator here. But so they want the left bound, then they want the right bound, and then they give me the same exact answer here, 4.482. You can't show your work, but the good thing for this particular question is it's saying just find the values. It doesn't tell you to show your work. For part 2, it says determine the end behavior of g as x increases without bound. So as x increases without bound is just a fancy way of saying what is the limit as x approaches infinity. Now we saw from the graph that if you have an ln graph, it's going to go from 1, 0, and then it's going to increase. It looks like it's going to level off, but log functions will eventually hit infinity. And then remember that your log graph is going to approach negative infinity as you approach 0 from the right-hand side. So how do you actually express your answer then? We're going to do limit as x approaches infinity of g of x, and then we're going to say that's equal to infinity. If you do not want to write g of x, you could also write it this way, limit as x approaches infinity, and then plug in the exact function that they gave you. Either one of these would be acceptable answers. If you do not put g of x or 2 ln x in the answer, then that would be considered incomplete because you're not expressing what function you're taking the limit of. Moving on to part C, it says determine if f has an inverse function. So a couple ways you could do this. One is you could plot the points. It makes this nice little Christmas tree, I guess. And then you can see that if you wanted to find the inverse function would be flip-flopping the points, right? So 1, 1 would be the same point. This is 2, 3, which would become 3, 2. This would be 3, 5, which becomes 5, 3. 4, 3, which becomes 3, 4. And then 5, 1, which becomes 1, 5, right? And so you notice that when we try to invert it, we will no longer pass the vertical line test. So for at least part 1, it'd be no, f does not have an inverse function. The nice part is if it says determine, you're not going to have to do extra work. Now, part 2 is the hard part, where it says give a reason for your answer based on the definition of a function and the table of values in f of x. A couple ways we can think about it. A function is invertible if and only if it is 1 to 1, right? So every x yields a singular y point, but this one is not 1 to 1. So you could say something along the lines of f of x is not a 1 to 1 function and therefore it is not invertible. Or you could say that when you invert the points, that you no longer get a function that passes the vertical line test. So 2 ways you can answer this question. I went ahead and wrote 2 separate sentences here, but I feel like the first sentence is enough to get full credit there. So in part 2, we're given this information about some ecologists. We're told that in 2015 t is equal to 2, there were 59 plants, so that's something that we're probably going to use soon. And then we get this other point. It's nice that they did the math for us here. And they told us that we can use this model equation here. We want to pay attention to what our units are, so t is going to be in terms of years, and then p is going to be the number of plant species. And then it says use the data given to write 2 equations that can be used to find the values for constants a and b in this equation. So we're going to plug in those points. So here's how I'm going to show my work. I'm going to say p of 2 is equal to 59. And then if I plug 2 into this equation, that means that ab to the 2 is equal to 59. Similarly, I can do p of 8 is equal to 118. And then that's going to yield the equation ab to the 8th is equal to 118. And so here's how I would solve this. A lot of people would use substitution, but I like elimination. So I'm going to take the bigger one and I'm going to divide it by the smaller one. And this is the same as saying 118 divided by 59. And if I simplify everything on the left side, the a's cancel out. And remember that when you take an exponent and divide by another exponent, we're going to subtract the exponents. And this is going to equal 2. So then b is going to equal technically plus or minus the 6th root of 2. I think that since we're talking about a real-world scenario involving growth, that it's more likely that my b is going to equal the 6th root of 2. Now if I want to go ahead and figure out what my a is, I'm going to plug it back into the equation. So then I get 59 is equal to a times b to the 2nd. So then 59 is equal to a times the 6th root of b squared, 6th root of 2 squared, excuse me, which is the same as saying 59 is equal to a times the cube root of 2. So then if I want to simplify this, a is equal to 59 over the cube root of 2. Now if I need to go ahead and plug it in my calculator, I just go here. So here's a couple ways, right? You could use the math function and go here to figure out the 6th root of 2, right? So I plug in 6 here. But also understand that if you have a radical, it can also be rewritten as 2 to the 1/6 power. You see that you get those 2 same answers here. And then 59, we're going to divide it by the cube root of 2, which can also be written as 2 to the 1/3 power. Now one thing you want to note is I love using this fraction function, alpha f1n over d, because that reduces some copy error, because sometimes when you're grouping things, you might unfortunately put things in the wrong order. So make sure that if you're not good with calculator fractions, that you use the fraction function here. So in this case, b is equal to 1.122, and then a is equal to 46.828. Part B, use the given data to find the average rate of change, so AROC. So here's how you show your work for AROC. We're going to say P of 8 minus P of 2 over 8 minus 2. We're given in the question that P of 8 is 118, P of 2 is 59 over 6. So then this is going to be 59 over 6. Express your answer as a decimal approximation. So then this is going to equal 9.833. And then just making sure that you always keep track of units. So the P units would be plants, and then the T units would be years, plants per year. So for part 2, I'm just going to use the average rate of change found in part 1 to estimate the number of plants for 10 years. So I'm just going to set up my equation like this, P of 10 minus, and I can pick either point. I'm just going to do P of 8 over 10 minus 8. And then that's going to equal 9.833. So then if I were to solve P of 10 minus P of 8, I would multiply both sides by 2. And when I multiply both sides by 2, I get 19.667. Now what is P of 8? P of 8 was 118, so I get P of 10 minus 118. And then I add 118 to both sides, so I get P of 10 is equal to 137.667. So in part 3, it says the average rate of change found in part 1 can be used to estimate the number of plants during the year T for T is greater than 10 years. And they're asking if these estimates will be less than or greater than the number of plants predicted by the model. So if we look at the calculations we did earlier, this was our A value and this is our B value, right? So then our starting point is around 46 and our B is greater than 1. So when you have a B that is greater than 1, that represents exponential growth. We would basically be starting at 46 over here, and then our function is going to make this kind of shape. Now, when we found that average rate of change, we did something called finding a secant line. So a secant line would be like finding this point here and finding this point here, and then connecting them with a straight line. So notice that between those 2 points, the curve will be under the secant line, but after those points, we're going to start growing exponentially and we're going to outpace our secant line. So for years greater than 10, our slope that we use to calculate would be an underestimate. So there's a couple ways you can explain this. One way you could explain it is by saying because the graph is concave up, or because the rate is increasing, the linear approximation would be an underestimate. So something like this would be okay. You could say exponential growth function, or you could say is concave up also. So in part C, we're asked which t value between 6 and 20 should the ecologist have more confidence in when using the model P? Well, we should be more confident using t is equal to 6 because that's already within the data points that we're given, right? We're given 2 and 8. So we should think that 6 is a pretty accurate approximation here. However, 20, right? 20 is very many years off. It's 12 years beyond today. So that would be what, 2033? So just based off of that alone, we could say that we should have more confidence in t is equal to 6. The ecologist should have more confidence in using t equals 6 for the model P because 6 is between the values of t we are given. Using t equals 20 would require the ecologist to extrapolate 12 years beyond the given values. Another way you could answer this question is to say something along the lines of, well, when you have a linear approximation is a good estimate for points that are close to the points that you're given. However, t of 20 is really, really far off from the points that we're given. And because an exponential function increases at an increasing rate, a point estimation that's really far off from the points that we're given would not be close to our secant line because our secant line has a constant rate of change. So for this question, maybe mentioning something along the lines of rate, concavity, increasing rate would be enough to get you the point for this question. I think something like this would be appropriate because we address the first point and then we also address the second point. I think too often students like to just say one thing as a reason, and sometimes it just comes up a little bit short of getting full credit. So moving on to question 3, this is a non-calculator question. We're given this picture of a clock over here, and then we're told that we have this clock face that has a 10 centimeter long moving hour hand. The center of the clock face is 200 centimeters from the floor, and then at time t equals 0, the hour hand is pointing directly up to the 12. Like it's midnight, right? The next time the hour hand points directly up to the 12 is at t is equal to 12, so that'd be 12 noon. And then as the hour hand moves, the distance of the end point of the hour hand from the floor periodically decreases and increasing. So we're tracing the movement. This is not the minute hand. This is the minute hand. This is the hour hand, right? And we're tracing this movement over here. So then the center of the clock is here. So this would be 200. The hour hand is 10 centimeters long, so it'd go up to 210, and then it'd go down to 190 over here. And so this is pointing up, and this is pointing up again. So if we start off our day at 0, which is midnight, it would be midnight, and the clock hand would be 210 centimeters above the ground, and then it would reach up again at 12 o'clock noon. So that would be this point over here. So then the halfway point would be 6 a.m., Hopefully you all know how to read a clock and know that the hour hand is pointing down at 6 a.m. So then this would be the quarter point, so it'd be 3 p.m. when it's pointing to the side, and then it'd be pointing to the side again at 9 p.m. So those would be your points over there. Then we're asked to find a sine function. Well, there's a couple things we should think about a sine function, right? A sine function starts at the origin and then goes up from here, right? So then where does the sine function start? If we use that exact one, we would start here and pretend like this is where the sine function starts. So what happened is if we were to use this sine function, it normally starts at 0, 0, but somehow it got shifted over 9 units to the right and up 200. So which are the things that indicate our units of horizontal and vertical shift? It'd be the C and the D. Remember with C, C is opposite the motion, so C would be a -9, and D goes with the motion, so that'd be a positive 200. Another way to think about D is D represents your midline, which is 200, so that'd be like that over here. Now what is A? A is the amplitude, which is defined as the distance from the midline to the peak, or the midline to the valley, right? What is the actual distance? It is 10 units tall, so we know that A is equal to 10. These are the most straightforward ones, but the complicated one is to figure out what B is. B is your frequency, and to find your B, you're going to take 2 pi, which is the value of the normal period of a sinusoid, and you're going to divide it by the new period. How long does it take to do a cycle? It's going to take 12 hours to do a full cycle, so B is 2 pi over 12, which can be simplified to pi over 6. So that's one way you can define your sinusoid function if you want a positive sine. However, you could also, if you wanted to do it, do a negative sine value, and a negative sine value is where you start at the origin and then you go down first. So then if we want to use a negative sine value, we could use G as our starting point. If we were to use a negative sine function, not all our values would change. The period and the frequency would not change, and the midline would not change. However, the amplitude technically would become -10 because I'm doing a negative sine function. And then the horizontal shift, instead of moving 9 to the right, it would move 3 units to the right. So C would be a -3. So those are 2 possible answers for part B. So moving on to part 3, it tells us to refer to the graph that we made. And then it tells us that the t-coordinate of J is T1. So where's J? So this is my T1 right there. And then the t-coordinate of K is T2, so that's my T2 right there. And so from T1 to T2, which of the following is true about H? H is positive and increasing. That's true, right? Positive means above the x-axis, and it is increasing. True. Positive and decreasing. Well, okay. So where's it positive and decreasing? It'd be here, right? And then negative increasing. Well, negative would mean all these values here would have to be negative. And then 2 says describe how the rate of change is changing on the interval. So when a question asks about how the rate of change changes, they're asking about the concavity of the graph. And if we look over here, the graph is concave up. It doesn't ask me to justify, but I'm going to justify anyways. Okay, here for question 4 in part A, we're given two functions g and h, and it says solve g of x is equal to 3. So I'm just going to go ahead and plug in. So log base 4 of 2x is equal to 3. To solve this, I'm going to change this into exponential form, or understand that to cancel out a log, it would be the same as raising both sides to the base of 4. This cancels out, so I get 2x is equal to 4 to the third. 4 to the third is equal to 64, so 2x is equal to 64. And then when I divide both sides by 2, I get 32. So that'd be my answer for part 1. Also remembering that my domain of g is only true for all positive numbers. And then if I want to solve h of x is equal to e to the 1/2, I'm going to plug in e to the 1/2 for the left side. And then this is going to equal e to the x to the 5th over e to the 1/4. Remembering that when you raise an exponent to another exponent, that would be the same as if you're just multiplying the exponents together. And then when we have two exponents being subtracted, when we have two exponents being divided, that would be the same as if we are subtracting the exponents. So 5x minus 1/4 is equal to e to the 1/2. To show our work, we could just set the exponents equal to each other, but understand that to get rid of the e's, you could ln both sides. So you get 1/2 is equal to 5x minus 1/4. And the nice thing about the non-calculator section of any one of these tests is if you're really bad with fractions, you can just kind of rewrite everything like this without doing the work. And as long as your answer is mathematically equivalent, you would get full credit over here. So this would be an acceptable answer. However, we could go ahead and do some of the extra work, right? 1/2 plus 1/4 is 3/4 divided by 5 would be the same as 3/4 times 1/5. So the exact answer would be 3/20. For part B, we're given this logarithm over here, and we're asked to rewrite j as a single logarithm of base 10 without negative exponents. So one of the rules is that if you have a coefficient, that can be brought up to an exponent within the log, and then anything that's subtracted goes in the quotient, anything that's added goes in the numerator. So the simplified form would be j of x is equal to log base 10 of, it'd be x plus 1 times 3 on top over 2 minus x to the 5th. So you can choose to distribute this 3 if you want. You don't have to, but here I have no negative exponents and no coefficients in front of the log. Part 2 asks you to rewrite k as a product involving tan and sine and no other trig functions. So if I'm going to rewrite this, I'm going to rewrite secant as 1 over cosine. And then I can rewrite cosine as cosine of x over 1. So if I see this denominator here, I'm going to multiply this by cosine over cosine to get a common denominator. And so if I wanted to rewrite it, it'd be 1 minus cosine squared over cosine. Now, if you have a cosine squared or something like that, that's when we're going to use our Pythagorean identity. Our Pythagorean identity is sine squared plus cosine squared is equal to 1. So then we can rewrite this as sine squared is going to equal 1 minus cosine squared. So if I were to rewrite this equation with a sine squared, it'd be sine squared over cosine of x. Now, sine squared can be rewritten as sine times sine over cosine. And if I want to isolate this, I could isolate these two together, and sine over cosine can be rewritten as tangent of x. and that's your answer. So part C gives you this function m and says find all input values in the domain of m that yield an output value of sine inverse of root 3 over 2. So this is the input right there, and then this is going to be your output. So what the heck is sine inverse of root 3 over 2? Remember that your sine inverse function is only restricted to positive pi over 2 to negative pi over 2. Where is sine root 3 over 2? Sine is root 3 over 2 up here, right? That's your y value on your unit circle. And in radians, we're going to do radians. That's going to be pi over 3. So then that's my output value. So I'm going to say pi over 3 is going to equal 2 tan inverse of root 3 times pi x. If I divide both sides by 2, I get pi over 6 tan inverse of root 3 pi x. So with this formula now, to cancel out this tan inverse, I could take the tangent of both sides. So then I get tangent of pi over 6 is essentially equal to root 3 pi x. What is tangent of pi over 6? Well, tangent is just sine over cosine. My sine is 1/2. My cosine is root 3 over 2. So this would be root 3 over 3 is equal to root 3 pi x. And so I'm going to divide both sides by root 3 pi, which would be the same as multiplying both sides by 1 over root 3 pi. This cancels out over here. This cancels out. So then I get x is equal to 1 over 3 pi. So for those of you who are prepping for this inaugural AP Precalc exam, here are some pieces of advice that I can give to you that I also give to my calculus students. 1, remember that if you have a decimal approximation that you should round to 3 decimal places. 2, if a question says explain or justify, make sure you write using complete sentences using the proper pre-calc terminology like average rate of change or slope or concavity or those types of words. And remember to always show your work. Bald answers do not get any credit. Do you have any questions on how I broke any of these concepts down? Well, feel free to leave a comment below, and thanks for watching.